Hello, we're on 2.01 pre-calc notes today. I had condensed some things in Unit 1 and took some things out, so it ended up being kind of short. So we are already on 2.01, and that's going to be on quadratic functions. Mainly, we're going to be talking today about putting a quadratic into vertex form and finding the roots from vertex form. So there's something kind of different though. Usually we call it vertex form, but our textbook that we use in this course calls it standard form. So because we do follow that textbook, we're going to be going by both names. So typically we have worked with our quadratics mainly in ax squared plus bx plus c, which is what we always called standard form. We're going to call that more like an expanded form is what we'll refer to that as. So standard form or vertex form is a form that you can easily take the vertex from. And you guys did this in algebra and algebra 2. And we're going to do it again, probably a little bit harder than the ones that you've seen in the past. And it's something that takes a while for it to really sink in, I think, for students. So it's good to continue to revisit. You want to remember your formula for axis of symmetry. Now, if you're using either formula, you can use our old standby, x equals negative b over 2a. Or if you have your vertex form or standard form, you could just say, well, I already know the h, so x equals h. The vertex from vertex form should be super easy to figure out. You're just taking the h and the k. So just like with all of your parent functions, this part inside the parentheses that's being added or subtracted to x tells you your left-right shift. It's opposite of what you think. The plus k on the outside tells you your up or down shift. So if we start with y equals x squared, our parent function, and we shift it h, right h, and up k, then our new vertex will be hk. If a, so your lead coefficient, which is here, same a is here, is greater than 0, so meaning it's positive, the function has a minimum. It's positive. It's a happy curve. It's smiling. If a is less than 0, meaning it's negative, then the function will have a maximum. So if it is sad, then it's going to be a frowny face, sad, negative. People are sad and they frown, and then you have a maximum there. So that's just kind of the basic info that you guys need to know. And hopefully that should all be review for you. Let's do a couple practice here. Sketch the graph and determine the vertex and axis of symmetry. First one, we'll do f of x equals 2 times the quantity x minus 3, quantity squared, minus 4. So this 2 out in front doesn't really tell us, it doesn't change the vertex at all. So if you're just trying to find domain and range, it wouldn't really matter. What that tells you, if it's a number that, a larger number, then it's a vertical stretch. If it's a smaller number, like a fraction, so less than 1, then it's going to be a vertical shrink. So make it wider. A stretch, think of taking your y-axis and pulling it out, stretching it up and down, and that would make the curve get more narrow. So the vertex from this should be really quick to find. So we're looking for the vertex. We're just going to take opposite of what's in the parentheses. So +3, -4, which is on the outside, your h, comma, k. Axis of symmetry also should be pretty quick with the vertex form. You take x equal whatever your h value is. So x equals 3. Why is that? Well, when you graph this, you're taking the parent function y equals x squared, moving it over right 3 and down 4. So that's your vertex. We know it's positive out in the front. It's +2, so it's going to be happy. It opens up. And your axis of symmetry is the line of symmetry that goes through the middle of the curve. It always passes through the vertex. So a vertical line will always have the equation x equals a number, whatever number it's passing through. And in this case, it's always going to pass through the x coordinate of your vertex. So x equals your h, or in this case, x equals 3. Let's do another one. F of x equals -3 times the quantity x plus 4 squared minus 1. Pause the video here, see if you can find your vertex for me and your axis of symmetry, and then do a sketch of your graph. All right, so you should have your vertex should have been -4, -1. Axis of symmetry would be x equals -4, left 4, down 1, and this one would open downwards because there's a negative in the front of that lead number, and that tells you if it's negative that it's going to be a frowny face, so it's going to open down. All right, next up, we're going to start completing the square. So complete the square to write f of x equals x squared plus 6x minus 5 in standard form. Again, that means vertex form. Then I want you to find the roots by completing the square. So I don't want you to start all over and find the roots using quadratic formula or factoring if it's possible. I want you to use all the work you just did to find the roots. So to complete the square, first thing you want to do is you want to get all of your variables on one side and anything that doesn't have a variable over to the other side. So we're going to add 5 to both sides. So now I have f of x, or a y here, so I'm just going to add that 5 to it. And then also notice whenever you're completing the square, it has to be a 1 in front of the x squared, and it is here. So we don't have to do any extra steps. Next, we want to find our b/2 quantity squared. So some of you, I know Miss Locke calls it the b box. So you're taking your b, so that's 6, dividing it by 2 and squaring it. So we're just doing this off to the side, 6/2 quantity squared. 3 squared gives us 9. So we're going to add 9 to both sides. All right, now we're going to combine our like terms over here on the left side. So 5 and 9 give me 14. For some reason I wrote an equal sign there. And then on the right side, I want to write it as a perfect squared binomial. So that's going to be x plus whatever b/2 was before you squared it. So +3 quantity squared. And then to get into vertex form, I just want to get it equal to y, so I'm going to subtract 14 from both sides. F of x equals x plus 3 quantity squared minus 14. And that's our vertex form. The next part asks us to find the roots. Well, the roots are where it hits the x-axis. And anytime you're along the x-axis, that tells us that y is equal to 0. So my f of x is the same thing as y. So I'm going to take out f of x and replace it with a 0. And I have x plus 3 quantity squared minus 14. And now I'm just solving for x. So I'm actually going to add that 14 back over because I want to get that x by itself. So I'm trying to isolate the x. So I'm trying to work my way inside. So now I need to get rid of this squared. So to do that, I'm going to take the square root of both sides. Don't forget your plus or minus anytime you take the square root. 14, there's no perfect square I can take from there, so I'm going to leave it as 14. The square root of something squared is just whatever's underneath the radical, so x plus 3. Last step, subtract your 3 from both sides. And always write that constant you added over first. So negative 3 plus or minus rad 14. So those would be your roots. And if you want to write them as x-intercepts, you could write negative 3 plus or minus rad 14, comma 0. So they were points. Okay, those are your roots. Okay, let's try another one. So the next one we're going to do is one that it doesn't have a 1 as our lead coefficient. So I'm going to ask you again to put it into vertex form. And then if I can get to that page, here we go. So put in vertex or standard form. I don't know why it's writing so funny right now. Put in vertex or standard form. Identify your vertex. Oh my. Just needs to catch up with me, I guess. Identify vertex and x-intercepts. Hopefully you can read that. So again, it says put in vertex / standard form. Identify the vertex and x-intercepts. So on the last one, our vertex here would have been negative 3, negative 14. But it didn't ask you to specifically state the vertex. So that's why we didn't write that one out. All right, so the equation here is f of x equals 3x squared minus 6x plus 8. Same thing we start off with in this one. We subtract the 8 from both sides. Any constants go to the left. Anything that has an x stays on the right. Now, we cannot complete the square if there's a number other than 1 in front of the x squared. So since it's a 3, and I'm not saying take out your GCF, I'm saying take out whatever number is in front of that x squared. So because it's a 3, I'm going to factor out a 3 from both these terms. So I'm dividing each by 3. So I'm left with x squared minus 2x. Okay, so now I'm going to add in those blanks. Minus 8 blank, x squared. I could have done this on the last step as well. Okay, so now we need to find that b box. So b over 2 quantity squared. Now here, remember, you want to use your new b of negative 2. You guys aren't newbies at this. So your old b would have been negative 6. You want to take the new b, the one where you've already factored out the 3, because this part in the parentheses right here, that's what we're completing the square for right now. So negative 2 over 2 quantity squared gives me negative 1 squared, which is 1. So I'm going to add 1 over here. Now I added 1, I physically wrote a 1, but I really didn't add a 1. I really added a 3 because that 1 is being multiplied by a 3 on the outside of these parentheses. So since I really added a 3, I need to add a 3 to this side too. So whatever I added here, I need to multiply it by this outside number when I add it to the left side too. And then we have 13 minus 8 is going to give us 5. Oh, no, not 13. Sorry, negative 8 plus 3 is going to give us negative 5. And here we want to write x squared minus 2x plus 1 as a perfect squared binomial. So we have an x. We take whatever it was before we squared it, so a negative 1. And just going to rewrite that again. Or you can think about it as you're just taking b over 2. So negative 2 divided by 2 is negative 1. And to get this into vertex form, I'm going to add this 5 over to the other side. And I get 3 times the quantity x minus 1 squared plus 5. Now this one asked me to find my vertex and then my x-intercept. So far I put it in standard form. My vertex is going to be positive 1, so it doesn't matter now what number's on the outside there. You just take the h value and then 5. And now we want to find our x-intercepts, or our roots, which is where y is equal to 0. So now we're going to take out the f of x and we're going to put in a 0 for that. But again, I want you to use this part where you've already got it into vertex form, because it should be faster, and it's good to practice that completing the square. And you know what? Let's make a note here just to remind yourselves here that you must have a 1 to complete the square. Okay, so now we're going to subtract over that 5, x minus 1 squared. Then we're going to divide by 3. Again, we're trying to isolate this x, so get all the way inside of it. So we're getting rid of everything around it first. So I have negative 5/3 equals x minus 1 squared. And then take the square root, plus or minus whenever we take the square root. We're left with whatever's underneath the radical over here. Now I have rad 5, negative rad 5 over rad 3. So I need to rationalize that. I need to pull out an I. So I'll have I rad 5. Remember, a negative under the radical, you pull it out and it becomes an I. I'm not allowed to have a radical in the denominator, so I need to multiply the top and the bottom by whatever that radical is. So that would give me plus or minus I rad 15 over 3 equals x minus 1. Now I'm realizing as soon as I get an imaginary number, I know I'm not going to have x-intercepts. But I'm going to finish anyway, because you could potentially have to do this stuff, and it's good review to see the rationalizing and all that. So x equals 1 plus or minus I rad 15 over 3. So there's no x-intercepts because it's imaginary. And you could have stopped as soon as you saw you were taking the square root of a negative all the way up here. That's when you could have stopped. But again, good practice to review that always. All right, so now we're going to do one more of these and then a different type of problem after that. So number 4, we've got, it's going to let me write here. Oh, apparently there's already writing down here. Let's start right here. Number 4, so write f of x, f of x equals negative x squared. Oh my goodness. It's not writing great right now. Sorry, 1 second, I just have to plug this in. So the next one we're talking about is negative on the outside. So you're going to want to distribute that first. Maybe this will help with the writing. I don't know if those things are related, but hopefully. Negative x squared minus x plus 30. I want you to put it in vertex form and then find the vertex and the x-intercepts. Vertex and x-intercepts. Okay. And sorry, I was trying to plug that in and I looked at the wrong line. The original I'm giving you is negative parentheses x squared plus x minus 30. And I want that in vertex form. Sorry about that if you already wrote it. Okay, so the first thing I would do is get rid of those parentheses by distributing that negative, which is what I had just written there. So negative x squared minus x plus 30. Now we need to complete the square. So the first thing we've done in the last problems is take away anything that doesn't have an x. So I'm going to subtract the 30 from both sides. So I have f of x minus 30 equals negative x squared minus x. Now I can only complete the square if there's a positive 1 in front of x squared. Since there's not, I don't take out a GCF, I take out whatever number's in front of the x squared. So that number happens to be a negative 1, so I factor out a negative 1, leaving me with x squared plus x. And I'm going to leave my blanks here. Over here, I still have f of x minus 30. Now I'm going to find my completing the square term off to the side, b over 2 quantity squared, which is 1/2 squared, which is 1/4. So unfortunately, that gives you guys fractions, which I know makes some of you a little bit uncomfortable. So we're going to add 1/4 into there. I forgot my line here. You're going to add 1/4 on this side too, except it's not just 1/4. It is negative 1 times 1/4. So it's actually subtracting 1/4. All right, so now, and you can do in your calculator, negative 30 minus 1/4. And actually, this would be a good time right here to pause and try to finish this problem completely on your own now that we've done a bunch of practice ones. And then check back with me. Okay, so to combine these, because I know some of you are nervous about the fractions, just put it right in your calculator. Do negative 30 minus 1/4 and hit math frac. You must give this to me as a fraction, not a decimal. That's extremely important. Here, again, it's whatever it was before you squared it, or your b divided by 2. So it's going to be x plus 1/2 quantity squared. And then all we're going to do is add over our 121 over 4. So I have negative 1 times x plus 1/2 squared plus 121 over 4. And then I want to find the roots. So that's where y is equal to 0. And we're going to put 0 in for this f of x. So we set the whole equation equal to 0. And then we're going to isolate that x value. So to do that, I'm going to subtract over my 121 over 4. And again, I want to work my way inside the x to get to the x. So I'm going to divide both sides by negative 1. So that's just going to change to the opposite sign. So 121 over 4 equals quantity x plus 1/2 squared. Now to get rid of the squared, take the square root. And again, you guys should be doing this one on your own and then checking back with me. So we have plus or minus square root of 121 is 11, square root of 4 is 2. And when we take the square root of something squared, it's whatever's underneath the radical. And then we want to solve for x, so subtract 1/2. Now this one is also, again, a little bit different because 11 over 2 and 1/2 are like terms. We don't have radicals in them this time. So there's no reason why we can't combine them. And if you don't, you're actually not going far enough. So I'm going to split them. I'm going to go down to my next page here. So I have x equals negative 1/2 plus 11 over 2. And then I have x equals negative 1/2 minus 11 over 2. And lucky for me, they have common denominators, makes it a lot easier. So 11 minus 1 is 10. 10 over 2 is 5, is one of my answers. And then negative 1 minus 11 is negative 12 over 2, which is negative 6. So our two answers here would be negative 6 and 5 for those roots for that one. Okay, last question we're going to do is write the standard form. Again, that's going to mean vertex form for us of the parabola whose vertex is 1, 2, and it passes through the point through the point 3, negative 6. So in order to do a problem like this, you have to have your standard form or vertex form memorized. So we know standard or vertex form is f of x equals a times the quantity x minus h squared plus k. And then it's kind of just we're filling in what we do know. So the vertex we know is our hk, and this point over here is x comma y, or in this case, x comma f of x. So first, the only thing I don't know that I need is a. So I'm solving for a. So first I know my h and my k, so I'll put those in. And now to solve for a, I'm going to substitute in my x and my f of x. So I'm going to put 3 in for x and negative 6 in for f of x. And now I'm going to solve for a. So I have 3 minus 1 is 2. And I'm going to follow my order of operations. So I have exponents, so that's going to give me a 4a. Subtract my 2. Thinking ahead here. And I get negative 8 equals 4a. Divide by 4. And a equals negative 2. So now I have what I need in order to write the equation. So now I just substitute in. You always leave an equation in terms of x and y because it's any point can be part of it, but the vertex will always stay the same, as will the a. So f of x equals negative 2 times the quantity x minus my h, which is 1, squared plus 2. So for your final answer, you want to sub in the a, the h, and the k. All right, and that is it for us for today. I hope that makes sense. If you have any questions, let me know, and pie out.